And here we are back again, and right in your screen now is a demonstration board from Microchip, which is using a different chip to what I'm using, but it's in the same family. It doesn't have any USB support. It's the PIC18F 45K20. It's a bit different applications. It's got the program header here, just a button and a variable resistor, the chip, an array of LEDs and resistors there, plus appropriate capacitors across the power there and there. And I think they did a bit on the bottom here. They put a resistor over there, which is what they recommend in their PIC kit documentation. Anyway, I got that and was trying it out. Pretty cool. Teaches me a few things. There's a stack of room for other stuff to be put on here. Some other peripheral chips, as you can see, surface mount devices. Right there in the center of the screen, you'd probably put like the rectifier that I was talking about not so long ago, and just solder heaps of stuff in so you could jump it across to your other demo board or breadboard like this. But I've got this version of the PIC18F4550. This is the demo board that they use at Microchip, or part thereof. I'm not sure that I've completely replicated it, but I've got most of the components, which I went through in a previous video. So yeah, it's got capacitors here which pump up the voltage so you can transmit. I put that on there just because I might want to use it for anything else in particular. Something that doesn't have USB on it, like over here. This has RX and TX on it. I might want to use that, talk to a computer over RS-232 or whatever. But right now it's connected to my breadboard, mainly for use with the USB header. It's just a USB-B, which you can see there, and it's got a header there so that I can plug some pins in to get the data lines, the D plus and D minus. And here you notice there's two jumpers so that it can be electrically isolated, because as you know, 5 volts comes down the USB line. If I don't want to use the 5 volts from the USB, then I can unplug these jumpers, and now it's not using the power from the USB, which, if I have like batteries or a programmer or something attached to my circuit, I don't want to be pushing power back up the wrong way. Similarly, the RS-232 Max chip is similarly isolated. I'm just using these massive ass cables because that's all I had at the time, and they really make for some angry soldering. I'll just detach this from the board and we can have a look at this angry soldering. And it's really bad with the light, but you can see it's pretty angry. Here are the pins which I plug into the breadboard with, and they're nicely spaced so I can give myself some room. And you can see there's some great big solders, and got like a back plane there of power. Really ugly looking. Not particularly excited about the quality, but we all live and learn, and it's practice that makes perfect, so there I am practicing. The tape's on there just because it's convenient to just grab it by the tape. The board, it's a class 2 Vero board, so it's a bit thinner than the other sort of Vero boards that you can get, like this one, which is obviously a class 4. I forget how they do it, but how they stated, but yeah, class 4 is got a lot more to it than this one, which is quite thin. So anyway, plug the USB into here, put the power and the data running up to the chip, so looks like I'm on my way and I can get my LCD pumping out some stuff. Here's the LCD here. It's just got just a ribbon cable attached to it, to a nice broad header. I probably should have split it out to 2 sideways, but it seemed quite convenient when I did it that way. Whereas I can just plug it straight in like this. Oh, there we go. All plugged in, and yeah, we're good to go. I can program my LED display. We've got brightness and contrast controls here, and we see the data pins back there. I'm running it in 4-bit mode, so I'll tell you a bit of a story about the 4-bit mode when I get it all going. And yeah, the programmer sits in this slot here. I've done a bit of a home handy job with this one. Oh my god, if I can actually plug it in. Oh, there we go. Sorry about the back of my hand. And I'm using PicKit 3, as you can see. It's quite handy, convenient. I've done a few things with it, including pushing power back up the wrong way, but it didn't blow up on me, so I'm quite happy about that. But I put the isolators in there just to make sure it doesn't happen again. I think that's it for the moment. I'll talk to you again soon, and thanks for watching, and please subscribe and rate. Thank you very much.